This brings us to our last example. Example 1D. Solve the quadratic equation by completing the square. 2y squared plus 5y plus 1 equals 0. As before, we begin by isolating our two terms that include the variable. That is, we want to put 2y squared and 5y alone on the left and move the 1 to the right side. To do this, we need to subtract 1 from both sides. That's going to give us on the left 2y squared plus 5y, and on the right equals 0 minus 1, which is simply negative 1. We now have our two variable terms alone on the left. Now notice, this is a little different than the examples we've done before. We have a number 2 in front of our y squared, and if you recall, our previous examples all had coefficients of 1. Now, in order to rewrite this into a perfect square trinomial, we want to get rid of this 2 to make it easy. That means we want to rewrite this to have a coefficient of 1. How do we do that? Well, the 2 is multiplied by the y squared. To get rid of it, we want to divide. 2 divided by 2 is 1. If we do it to the first term in our equation, we actually have to do it to every single term in our equation on both sides of the equation. So, 2 divided by 2, that gives us here on the left 1y squared. 5 divided by 2, that gives us 5 halves y. And on the right side, negative 1 divided by 2 is simply negative 1 half. Our equation is now set up to where we can create a perfect square trinomial on the left side because the coefficient on our y squared is 1. How do we do that? We begin by adding a blank to both sides. We add a blank to the left and we add a blank to the right. What is it that we're going to fill in the blank with? Well, let's see. We take half of the middle coefficient. It's fractions. Oh, but don't be alarmed. We're simply going to take half of 5 halves. How do we multiply fractions? 5 times 1 gives us 5. 2 times 2 gives us 4. That tells us our magic number is 5/4. What do we put in the blank? Well, we put 5/4, our magic number, squared. And what's 5/4 squared? Well, let's see. 5/4 squared is simply 5 squared, which is 25, over 4 squared, which is 16. This means the number that we put in both of the blanks is 25/16. 25 over 16. Good. So besides the fact that this equation has fractions in it, we've done everything perfectly, and it should be easy here on out. We want to factor the left-hand side. How do we do that? We want to rewrite it as a binomial square. And again, this is simple because we simply use our magic number 5/4, and that's what goes inside our parentheses. Y plus 5/4 squared, if you multiply it out, will give you y squared plus 5 halves y plus 25/16. Now, the right side's going to take just a little bit of work. We have to add two fractions together. Negative 1 half plus 25/16. We want to add these up so we can simplify and get a number on the right. How do we add unlike fractions? We need to get a common denominator. What's our common denominator of 2 and 16? Well, that's simply 16, which means we have to multiply our first fraction on the bottom by 8. 2 times 8 will give us 16. And if we do it to the bottom, we have to do it to the top. That tells us we're simply adding on the top negative 8 over 16 plus 25 over 16, right? And continuing to add these two fractions, now that we have like denominators, negative 8 plus 25 is simply 17 over 16. Everyone got that? So this is what our right side simplifies to. 17/16. Perfect. Now, we're set up to apply the square root property. We have a quantity squared equals a positive number. How do we apply the square root property? Well, the object inside is equal to plus or minus the square root of the other side. In other words, applying the square root property, we have that y plus 5/4 equals plus or minus the square root of 17/16. Good. We finish by isolating y. That is, we want to subtract 5/4 from both sides of our equation. What does that give us? On the left side, that gives us that y equals, and on the right side, negative 5/4 plus or minus the square root of 17/16. Now notice what I'm going to do. I'm going to break it up into two square roots, the square root of 17 and the square root of 16, because our rules for radicals allow us to do that. And the reason I did that is that notice I can simplify the square root of 16 into 4. So that actually gives me y equals negative 5/4 plus or minus the square root of 17 over 4. Now we can leave our answers like this, or because we have a common denominator, we can also rewrite our answer to be over that single denominator. So we could also rewrite our answer as y equals negative 5 plus or minus the square root of 17 all over 4. So let's finish by writing our answers in the form of a solution set. That is, the answers to our quadratic equation are negative 5 plus the square root of 17 all over 4 and negative 5 minus the square root of 17 all over 4. Both of these answers, which when substituted back into our original equation, solve and make it true. Now I want to quickly summarize by telling you that what makes this equation different from our previous equations is that it had a coefficient in front of the y squared. So after you isolate for your y terms, you want to divide all the terms in your equation to get rid of that coefficient and make it a coefficient of 1. Then you proceed to solve by taking half your middle coefficient, squaring it, and then putting it into the blanks, which are added on both sides. Rewriting this perfect square trinomial as a binomial square, and then finishing with the square root property. Good luck, and I hope you have fun completing the square on quadratic equations.